so it's the turn to take up the solution for the next question. So this is question number 9. This says a metal rod of length L at temperature T when heated to temperature T dash expands to new length L dash. These quantities are related as L dash is equal to L in the bracket 1 plus alpha in the bracket T dash minus T, where alpha is the constant for that material and called as coefficient of linear expansion. We need to find out the correct SI unit of alpha. See here, alpha is what? It is the coefficient of linear expansion. Now, we are given here that these quantities are related to each other with this expression, that is L dash is equal to L in the bracket 1 plus alpha in the bracket T dash minus T. Now, this alpha in the bracket T dash minus T, that is basically the change in the temperature. So, the product of alpha and this delta T, if I called it to be the change in the temperature, this should be unitless. Okay. So, it means I can write here in the solution that as the expression gives, L dash is equal to L in the bracket 1 plus alpha into delta T. This is what I am writing this. So, this alpha delta T should be unitless, and hence I can write that alpha is going to have the units of the reciprocal of temperature. So, what is the SI unit of temperature? That is Kelvin, and hence I can write it is going to have the units Kelvin inverse. So, which option is the correct option? That is option number C. Let me just put it into the box as well. I can write here the correct answer for this question is option C. I hope this question is quite clear to you. Let's move quickly towards the solution for the next question. Hey, so it's the turn to take up the solution for the next question, that is question number 10. This says a paramedical staff nurse improvises a second pendulum. The time period of second pendulum is 2 seconds. That is also given to us here in the question. And this question says that the nurse improvises the pendulum by fixing one end of the string of length L to a ceiling and the other end to a heavy object of negligible size. Further, the question says within 60 oscillations of this pendulum, she finds that the pulse of a wounded soldier beats 110 times. A symptom of bradycardia is pulse less than 60 per minute and that of tachycardia is greater than 100 per minute. We need to find out the length of the string and also the soldier has the symptoms of. Now, here as you can see that within 60 oscillations of this pendulum, she finds that the pulse of wounded soldier beats 110 times. It means 60 oscillations for this pendulum will be equal to 2 minutes, and in 2 minutes the beats are 110 and beats per minute are going to be 55, and hence the soldier has the symptoms of bradycardia. Okay. Further, we also need to find out the length of the string, so which we can find out by just substituting for the time period, which is 2 pi under root L by G. Now, when you will substitute here the time period to be 2 seconds, you will find out the length will approximately comes out to be 1 meter. So, if you have a look at the option, you can simply see here that option A is the correct option, and hence I can just put it into the separate box, and let us write it here also that correct answer for this question is option A. So, I hope this question is also very clear to you. Now, let us quickly move on to the next question. Hey, so here we have our next question on the board. In this question, we are given this circuit diagram, and in this circuit diagram, each resistance is R. In order to have an integral value for equivalent resistance between A and B, the minimum value of R must be. Now, here in this circuit, all the resistances is R. The value of all the resistances are. So, if you just see here, this is R, this is also R, this is also R. Now, here you can see these two are connected in parallel. So, what is going to be their equivalent resistance? That is R by 2. Now, this R by 2 is in series with this R and this R, and hence the equivalent resistance for this part of the circuit is going to be what? That will be 5R by 2. Now, here you can see that this is similar to this, and hence the equivalent resistance for this part is also going to be 5R by 2. Now, the upper and the lower part are again connected in parallel. So, if you just connect these two resistances in parallel, that is this 5R by 2 and 5R by 2, what you are going to get? You will get the equivalent resistance of 5R by 4. Now, this 5R by 4 is in series with this R and this R. So, simply this 5R by 4, when you will connect it in series with this R and R, you will get the equivalent resistance of this complete circuit. Let me just change this color. You will get the resistance of this complete circuit as 13R by 4. Now, here you can see this upper circuit and this lower half. These two are again symmetrical, and hence if we have calculated this as 13R by 4, similarly the equivalent resistance for this part of the circuit will also comes out to be 13R by 4. So, here you can have a look at this simplified version. So, here you have this resistance as R, this is 13R by 4, this is also 13R by 4, and this is also R. So, when you will just calculate the equivalent resistance in between these 2 points A and B, that will come out to be 29R by 8. Now, as per this question, we need to find out the minimum value of R so that the equivalent resistance can have integral value. Now, if you have a look at the options, you can clearly see here that this R equivalent will be integral only for option B and option C, and if we need to choose here the minimum value, so what is going to be the correct option? That is going to be option B, that is 8 ohm. So, I hope this question is also very clear to you. The correct answer for this question is option B. Now, let us quickly move on to the solution for the next question.